Here's the video for section 10-12, complex numbers and quadratic equations. Complex numbers can be multiplied. So as you look at the example, I hope you notice this has the pattern to use FOIL. 2 times 5 is 10. Now the outer product, 2 times 7i, that's positive 14i. Then the inner product, 3i times 5, that's positive 15i. And then the last, 3i times 7i, that's positive 21i squared. These two middle terms both contain an I, so they can be combined. So 10 plus 29i plus 21i squared. If it wasn't the letter I, we would be done. But because the letter I is representing the imaginary unit, we can simplify this last piece that says I squared. Because what does I squared equal? I squared, remember, is negative 1. So then 21 times negative 1 is negative 21, and that combines with the 10 at the beginning. The final result is negative 11 plus 29i. So when you do FOIL with complex numbers, it doesn't create a trinomial like we're used to with variables. Instead, it actually creates a complex number again. Do you remember solving quadratic equations using the quadratic formula? Now that we know about complex numbers, we can use the formula even if the discriminant is less than 0. In that earlier chapter, we learned that the b squared minus 4ac, which is in the square root in the quadratic formula, we learned that's called the discriminant. And if that ever turned out to be a negative number in that earlier chapter, we said that there were no real solutions, that there would be two imaginary solutions. But we didn't actually find them, and now in this chapter we will. So let's solve this equation using the quadratic formula. X equals negative b, so that's negative 2, plus or minus the square root, b squared, so that's 4, minus 4 times the a times the c, all divided by 2 times a. Now let's simplify in that radical. 4 times 1 times 7 is a 28, and 4 subtract 28 is negative 24. Again, in that last chapter, at this point, we would say no real solutions. But now that we know about imaginary numbers, we can continue and simplify this radical. Think of the negative 24 as being 4 times 6 times negative 1. Then the square root of 4 makes a 2, and the square root of negative 1 makes the symbol I. The 6 stays in the radical. Finally, let's reduce those 2's. So we get negative 1 plus or minus I square root of 6. Numbers such as negative 1 plus I square root 6 and negative 1 minus I square root of 6 are called conjugates of each other. The word conjugate is a vocabulary word that we had in an earlier chapter. Now we see that word used again and in the same context. Conjugates are binomials where the only thing different is the symbol in the middle. One of them has a plus, the other has a minus. If you multiply conjugates, then you get a positive real number. Take a look at this example. 3 plus 2i times 3 minus 2i. This has the look of FOIL. When you do FOIL, the outer and inner products end up being opposites and cancel away. We're used to that happening from an earlier chapter, but this last thing is going to simplify to a real number. Again, because I squared is just negative 1. And then 9 plus 4 makes the final answer 13. When you multiply an imaginary number by its conjugate, you get a real number. So this provides us a technique if we ever need to change an imaginary number into a real number. Take a look at this next problem, where we're asked to simplify this. When simplifying something that has an imaginary number in it, we don't want to have an imaginary number in the denominator. so we need to have a way to remove the imaginary unit from the denominator. And it's this idea about conjugates that will help us do it. Let's times the top by 3 plus I and times the bottom by 3 plus I. 3 plus I is the conjugate of the 3 minus I. Let's use FOIL in the top. 2 times 3 is 6. The outer product is 2I. The inner product is 15I. And then we have 5I squared. Down in the denominator, 3 times 3 is 9. The outer product is positive 3I. The inner is negative 3I. And then negative I times I is negative I squared. Now let's do the combining. 6 plus 17I plus 5 times negative 1. Remember, whenever you get I squared, that's negative 1. Down in the denominator, let's do some combining. 9, and then those i's cancel away, and then we have negative of negative 1. The final result is 1 plus 17I all over 10. We removed the imaginary from the denominator, so now it's simplified. Let's summarize this lesson. We did some math using imaginary numbers. One of the skills was to solve a quadratic equation using the quadratic formula, and if you get a negative in the radical, you can keep going by using the letter I in your answer. The other skill we worked with was simplifying, and if there's ever the symbol I in the denominator of a fraction, you can multiply top and bottom by the conjugate in order to fix that.